Everybody, welcome back to the channel. This is going to be a little bit of a different video. I'm going to be sharing a portion of a live lecture I just recently gave, and I'm going to do more and more of this going forward. It's a little bit more raw, it's a little different, it's not edited at all. It's going to be very rough around the edges, but it's pretty much what I do in the classroom with some of my students. I take requests from the students. Hey, what's a shot they want to see? And I do a bonus live lecture and I try to cram it into an hour, sometimes 2 hours. And here's an example of one where we do a penetrating shot, ground penetration, where we have rocks that come up, kind of magical, inspired from the TV show Avatar on Netflix. So, with that said, let's go ahead and just dive in and have a little bit of fun.
Ground, dive in. And again, I'm going to approach this the way I would do it in production. So the way you'll see, like, man, why are you teaching it this way? Well, the way I'm teaching it to you the way is a lot easier to understand. So we'll do a box, and we'll just make a ground here, copy parameter, paste relative reference. But you'll see the tricks that I am teaching you guys, though, I use all the time. But I need to invert this, so I'm going to say negative. And we'll say 0.1. And we'll say 5 by 5. Maybe, yeah, we'll just do 5 by 5 for now. And let's go and set this up for fracture. So we'll do that ISO offset. $100. Hey. We'll scatter. And so this is a little bit of a deviation from what we teach here at LA Film. So I'm going to do like 100 for right now so you can see it, and then we'll up-res it later. But I actually will use the Voronoi fracture, but I don't use it the way you think I'm going to do. So a lot of students will be like, oh, you're done. No, I'm actually going to take this data that I just created here and use it to run a different fracture. The reason for that is going to give me more control, and I can create some really cool looking data. So right now, I'll probably will create something that's a little more soil looking, maybe, but still hard. Like, let's think like dried desert mud, okay? So we'll do that. We'll do a blast here. And I'm going to blast the input. This input right here will give me quite a bit of groups to use, and you'll see some name attributes, but I'm going to blast the inside, or blast everything but the inside. And it leaves us with this. Now, it's not usable geo yet, so I need to clean it up. So I'm going to fuse the points together because it creates duplicate points. And we'll clean the geo, get rid of overlaps. Okay, so I'm going to get rid of the overlaps. Now this is usable geo. But the problem, though, is this is actually the same size as the ground that I have. So let's go ahead now. We'll throw a bound down here. And we'll run the ISO offset off the bound. And what a bound basically does, it takes all the information on your scene and creates a bounding geometry around it. So like right now, the bound is just a rectangle. But let's say I drop a sphere. It'll still be a rectangle, but you'll see it'll change to the dimensions of the sphere. So here's the sphere, here's the bound. So now at this point, let's go ahead and create an actual good looking ground. So the way I'll do it, I'll do a VDB from polygons. And this is a hack that I use to increase resolution. So we'll say 0.01. And we'll convert it back to geometry. So convert VDB. Similar to what I showed you guys with the height fields earlier. I'll convert that to polygons. And you'll see I'm at 500,000 polygons here. So if I go up here to smooth, you'll see that we have a lot. Which will allow me to do a lot of deformation with this. So we'll do attribute noise. This is what the mountain node's made out of. I'm just doing the noise itself. We'll run P. And we'll do Worley Cellular. Okay. And on the Worley Cellular, I'll just play with this a little bit. And I want to get like some nice looking ground here. And you can see how quickly I can get up and running with just, playing with my parameters. Let's say 0 here. And then we'll say maybe 0.1. No, that's 2. Let's do 0.5. There we go. This nice looking ground. Okay. This will now modify the bound. So the bound will get a lot bigger. And my fracture will get a lot bigger. And now if I blast and I come down here to the clean, there we go. It's a lot bigger now. Okay. And then I use that Boolean fracture off of that original geometry. This takes a few seconds, but what the Boolean will do is it'll take that information that I create off the Voronoi now and create cutting planes, and I can manipulate those cutting planes. So to show you it, here's the exploded view, and there we go. Really cool. We get these weird cutting planes, okay? But now let's actually give this a little bit of realism to it. Right now, these are just hard edges. Nothing breaks like that. So we'll come over here to the clean, and we'll do a remesh underneath. We need to increase the resolution here as well. And I'm going to go up, create a null. We'll call this scene controls, Control S. Edit primary interface. Visible. And let's go ahead and do a float here, and we'll call this geo resolution. We'll call it geores. I accept. I'm going to start with 0.05. Copy this. Dive in, and we will, on the remesh, paste relative reference here. Okay, and this is going to be the size in between lines essentially, and so that's gonna govern how many triangles I get. And you'll see that's not that many yet, so just bear with me. But I also want to take that value and into the VDB from polygons. We're going to paste that here so that everything is pretty procedural. And so now I have my scene controls up here. We'll color this one green. And I go to, let's say, 0.01. It's going to take a minute, but you'll see it'll drive my resolution through the roof. And there we go. All right. So I can work at 2 different resolutions now. So there we go. And then after that, we can drop attribute noise. And on this attribute noise, I'll just do a position. Make sure you're not on along the vector. That's why I'm not doing the mountain, because the mountain node by default has this on. And we could just add some noise here. Just lower the element size so they go more. I'm just doing a simple simplex one, but I usually will layer this. So like I'll do a Worley cellular here. And then I'll do another attribute noise on top of that. So it's be like noise level 1, noise level 2. Okay, and then this one will also be peak. And we'll lower the amplitude a lot here. This will just add another layer of noise on top. Okay, but one thing to be aware of, when you start adding in a lot of noise, it will start to throw a fit in your Boolean fracture. Yeah, see, it's throwing a fit. I only want the points where the geo is going to be lifted. It's a waste of geometry out here. So let's go and create our impactor objects now, essentially. And so we'll do a sphere. And I'm going to go ahead and do a scatter. Yeah, we'll do scatter from here. This is going to be on the surface. That's fine. And I'm just going to do 3 points. I'll do a copy 2 points. Okay, so geometry. So we have 3 points there. And on this sphere, we'll go ahead and go to polygon mesh, or sorry, polygon. And let's just increase this to 25. And we'll do mountain. Something like that for right now. Okay. Now the problem is they're identical. So we can do a couple of randomizations here. So we do attribute randomize, or we could do an attribute noise vector. And you can see they start to turn here. I'll switch this to normal. We can just play with that. And then I can play with their size. Attribute, noise, float. And you'll see that by default it's set to p-scale. But I'll do a min-max. I want a minimum here. So we'll say 1 to 1.5. Or maybe we'll do 0.3 to 1.5. There we go. And then we can play with the element size. And at this point, what I'm going to do is before the Voronoi fracture, I'm going to do a Boolean here. So Boolean fracture. This will be my cutting plane. Take a look at that. And if I do the exploded view, you'll see what we got. And so I have these these three areas. Oh, that didn't quite do what I wanted to do though. Let me see why. Because the scatters are pretty far out, so we can transform them. Now it's going to transform to the origin, but that'll be fine. I'm going to lower the p-scale here. The p-scale is multiplying to this scale right here. So if we go to 1.5, they'll get smaller. And then if I go to the scatter and I play with the seed, it'll change where they're located. Oh, that works. Okay, that's going to be better. And there we go. Right? So what I'm getting is these three holes. Right? We're just going to get the bending coming through the ground there. And these are where I want to fracture. So underneath here, I'll do a split. And I'm just going to hit the icon here, this arrow icon. I'm going to press 9. Hit the gear icon, attribute, name. And I'm going to select the three names that I want. I'm holding down shift, hit select, hit enter. And now these will be split off. Okay. And we're going to fracture all three of these individually. But before I do that, first thing I want to do is I want to call this ground. Actually, we'll do it down here. We'll come down here. We'll do an attribute wrangle. Primitive. And if I look, you'll see that I have 0 through 3, I think. So 0, 1, 2. Okay, so 0, 1, and 2. This kind of worked out in my favor. But if that didn't work, I would have to use a for loops to fix it. But since it worked in my favor on primitives, I'm going to rename these. We're going to say s at name equals, in quotations, ground active underscore, quote, close quotation, plus s at name. And now the name will be renamed to the ground active piece 1. So this basically is ground active 1, ground active 2, ground active 3. Okay, so we give them their own name. And then over here, we'll do an attribute wrangle. And we will call this one under primitives s at name equals ground inactive. And we'll just leave it that. So we have the 4 pieces named. Okay, so there we go. Looks like a really weird face, but worked out. Okay, now we want to redo this whole process. But we've already done the skeleton. This is the beauty behind Houdini. You build the skeleton, and then you just reuse the skeleton. So we have the skeleton of our fracture here. And I'm going to start to set this up for subfracture. So we'll do a for each named primitive. And this I'll be able to run a process off one of these, and then I can run it again for each one of them. Same process. So okay. We'll need a meta import node for later. And we'll just move this all the way down here for now. And we'll do this chunk at a time. So we'll bring the bound up here into the bound, right? So now I have this bound. You'll see it's just working on this piece. And there is my fracture. The scatter will be the same. but I want to change the global seed from each one, or else I'm going to get the same scatter. So a way to do that is to source in an iteration from this node right here. I'm just going to control C. So I'm control C, copying this node, come down to the scatter, and we're going to write an expression. We're going to say detail. In quotations, I'm going to paste that node. So that's in quotations, paste that node. And then I'm going to say, in quotations, iteration, because that's the attribute I want to iterate over. And then 0. And now you'll see that this has a global seed on it. It'll be 0, 1, and 2. I'll have 3 global seeds on it because you have an iteration 0, iteration 1, iteration 2. And on the scatter as well, at this point, I'm going to increase the scatter now to 200 because we want a lot of pieces. We'll run this to the blast. There it is. Fuse, clean, remesh, noise level. And now the Boolean fracture will go off of the geo up here. And there we go. Now I have my Boolean fracture of those pieces, although we do have some issues right here. So let's try and diagnose some of this. One thing that might be happening too is I need to increase, oh, there you go, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1. So I needed to increase the padding. There we go, we fixed it. So basically this takes the bounding box and adds padding on its edges so that we have better and more defined edges. So we'll say 0.15. Yeah, it's fixed now. Orally cellular. There we go. And we could probably, under the remesh, get rid of this now. It'll take a second. It'll be really slow. But there you go. You'll see we're even getting these small little chunks that we can use down the line. Oh, all right. Okay, let's bring this down now. I'm going to hit save. It's going to throw this in, and we'll now iterate over all the pieces. This might take a second. There's one thing I didn't do, but we'll do it here in a second. And there we go. So exploded view. Boom. And then once we're finished, we'll go even higher resolution than that. But for one thing that I need to go fix, so we'll come over here to the Boolean. I'll go to append. And we're going to append underscore piece underscore to auto. And so what'll happen is each piece, you'll see underscore piece 2, piece 475. Or maybe we'll even call it sub. Here we go. So each individual piece gets its own unique name. That's important. Now, another thing that's also happening, if you look, the Boolean fracture does try and build you a constraint network. I actually want this constraint network, okay? We're going to build a layered constraint network, but I do want this. So let's go ahead and pack this together, RBD pack. Now, this isn't the same type of pack that we use for simulating. This is a way of taking 3 different variations of geometry and putting it under. So it'll be able to take your proxy. It'll take your proxy, your constraint geometry, and your high-res geometry and put it together. Now, we haven't built proxy geometry yet, so we're going to do it right now. By the way, I'm doing a simplified version of the RBD material fracture. That's all I'm doing. Simplified version of the RBD material fracture. I don't ever use this node anymore. I know we teach this node, which is fine, but I don't ever use it. I hate it. It's so slow, it's so clunky, and it gives you issues. So we're going to take the high-res geo into my geo right here, constraint geometry into the constraint, but we need to build a proxy. So let's do that now. And to do that, I'm going to do a convex decomposition. And to see it work better, I'm going to do blast from the high res right here real quick. Hit this button, and let's just go ahead and pick, I think we're still in name. Yeah, we are. We'll just pick one. So I'll just pick this one, hit enter. Okay. Throw this in a convex decomposition. And basically, this is going to just create a low poly representation that we'll use for collisions later. But we'll lower this resolution all the way down. And you'll see what's actually happening, right? So here is the original geometry, and there's the convex decomposition. And it just lowers the amount of points that you have to deal with. So like here's the high res, right? 943 points. The low res actually has higher right now because they're written really low. So let's see if we can. Yeah, we kind of need that. We might even need further than that. Something like that for proxy. but it won't have all the crazy geometry on the inside. Create this proxy here, and now I can just get rid of this blast. It's going to be slow, but you're going to create this proxy of all of this, and we'll throw this into here, RBD pack. This will now come out into here. I'll switch to manual now. And we'll do RBD unpack. And then I'm going to do my first cache node, RBD IO. This is just a cache node specifically built for rigid body dynamics. Okay. And we'll call this Geo RBD cache. Let's go up and build my controller. So edit parameter interface. I'm going to take this, right click, put it in a folder, and we'll call this RBD controls. RBD controls. And I want this to be a simple. Apply, accept, there you go, RBD controls. And then let's go to edit parameter interface. And now let's go ahead and do what I did earlier with you guys on the actual assignment. So min max integer and string. Well, cache location cloc frame range. And you'll see the stuff that I'm teaching you in class, it's the exact same stuff I would do in a studio. And we'll call this version cverse. Take these three, right click, put parameters in a folder, and this folder we'll call cache settings. And we'll do borderless as well for now. There we go. So cache, oh, not borderless, sorry. This will be simple. There we go. Cool. One, we'll go ahead and write the $F start, $F end, and I know this one. So $hip geo, and we'll call this demo1 / save. So we'll copy parameter. And this will be faster if I go to split build. You can use the games one as split build. I've built my own split build VFX. I'll show you guys how to do that later, by the way. And we'll come here. Oh, actually, we'll do it from here. Cool. And I'm going to do two. We'll do a file cache here because we're going to need one for later. And let's go ahead and set this one up. So copy parameter, paste relative reference, paste relative reference, copy parameter, paste relative reference, paste relative reference, copy parameter, paste relative reference, and then paste relative reference. That way I actually have the file cache node set up to duplicate later. $OS, let's get rid of the advanced hardened base name, advanced hardened base name. All this looks good. Hit save. All right, we're in good shape. And this first one is not time dependent, so we'll just turn that one off, and we'll hit save to disk, and this is going to take a minute. So, and the regular geometry, my high-res geometry, there it is. That's what we wanted. But I also have this proxy geometry that I created for later. Okay, very similar to what's happening inside of your RBD material fracture when you use that. We'll actually sim this one. Now, the other thing that's also that came out of this is a constraint network. There we go. We have constraints. So let's use these constraints now. Let's set that one up, and then we'll go set up the geo. So for me, I set up my constraints a little bit unique. So I'm going to drop an attribute wrangle, and I have legacy presets that I have saved up here. I have this glue standard 1. So we're going to use that one, and you'll see it initializes the strength. So I'll say channel float strength in this case. I want to control that, and we'll just start with, let's say, 100. Okay. We'll call this set glue. I'm going to drop another attribute wrangle. I'm going to give that glue some variance. So up here, I get another one, and we'll call glue variance, and this just creates variance. By the way, do you remember the RBD constraint properties I dropped when I was showing you guys the wall breakdown? I'm just doing it in Wrangle. I'm writing my own code for it. The reason why, it gives me more control. And more control, and it gets rid of all the extra attributes that I just don't need, right? This is just faster. So later this month, I'll show you guys how to build the templates. But you'll see constraint name is glue. I actually want to change this one to position, though. I don't want all. Okay, so position, but glue. Now, another thing that I'm going to do is when the glue constraints break, I don't just want them to break. I'm going to turn them into a soft restraint. So basically, there'll be a lot to break, but then they're going to stay soft and almost act like Jello. So when something penetrates through the ground, they kind of roll up instead of, right? So that's the secret sauce. So we'll call this glue variance, and then we'll call the next one attribute wrangle, which I don't have a template for this one, so I have to build it. So primitives, we'll say s at next constraint name equals soft. S at next constraint type equals position. Those are in quotation marks, by the way. Cool. So we have those, and now my null, and we'll call this out geocon. Color that black. Okay. All right, let's go set up the actual geometry. So I'll do an assemble. We don't need anything crazy here, so we'll just call this packed. There we go. That looks great. And now we have our geometry. Out geo. All right, so we have our two primary. Now, the next thing I need to do is I actually need to go grab this, the containing geo, and I also want to constrain. We're going to create some more constraints that work side by side to keep that geo from collapsing. This is going to be like a collision as well. So to do that, we're just going to go ahead and do. Let's do a, we'll do it the easy way. So we'll do a Voronoi fracture here. So we're actually going to fracture the outside, but it won't be as intense. So ISO offset, scatter. And one thing we can probably do, actually, we'll just do it this way. That's too many points, though. Let's do 100. Forgot to turn this one all the way up. There we go. Cool. All right, so I have this nice scatter here, and we'll have points along the side. And I'm going to then assemble this. Let's do append, and we'll call this piece like so. And what we'll have is ground inactive underscore piece. We'll pack it. Okay. And let's go build a constraint network. To do that, I'm going to drop an add node, and we're going to delete all of that. So we just have these points here. And let's come all the way down here. And then from this assemble, I'm going to merge. We actually want to drop another add node here too. So add. And this is what we get. And I'm going to draw lines from here, from the interior to these ones. So we could do a connect adjacent pieces. And this will just start to draw lines for us. And let's just go ahead and max connections, and we'll just increase the search radius. And there we go. So now we have some glue that will maintain here on the interior. But I don't want any glue constraints here inside. So we have to do a couple of, we have to do some finagling. All right. So to do that, I'm going to do a color here. We'll color what we don't want black. And then what we do want over here, white. Or we could do like pink right now so it looks, so we can see it better. Okay. Let's hit D here, go to background, I'll do dark gray so we can see it better. And we're gonna delete all the ones that don't have a color here. And so I'll do an attribute promote. And this is gonna allow me to take an attribute from one like component to the other. So right now, the color is on point. I wanna move it to the primitive. And then we could say attribute wrangle here. And say if at CD, well, we could do red because it's purple. So say if at CDR is less than 0.5, remove prim 0. So basically the first one just means on this geometry. So the way inputs work, so we have 4 inputs, right? It's 0, 1, 2, 3. That's how inputs work on any node. And we want to remove the prim num, so that number of primitive. And we want to put the next one just, it's a 0 or 1 indicator. Do you want to keep the points or do you want to delete the points? 1 is yes, 0 is no. And so 0 basically means keep the points, 1 means delete the points. I know it's kind of weird how they do it. Close that up. And then I need to run this over primitives. And now everything that's black is now gone. That's what we wanted. We did not want any of the constraints from before. Okay. Got a couple of constraints there that might be worrisome, but that's okay. And then at this point, I could just copy all of this. And now we have glue, variance in attribute wrangle here that says the next constraint type. And we're gonna make some changes here. So for the strength here, we'll say, you know, we'll start at 10,000. We'll keep the variance there. And then we'll definitely do the soft next. And we'll call this out con to edge. So we have 2 constraint networks now. Last thing, let's go get the geo. So from here, we'll do attribute, or actually we'll just do a null. Okay. We do need an attribute wrangle. And I want to inactivate these pieces because when the object comes through, I do not want them to activate. So we'll say I at active equals 0. These will not simulate. Call this out edge geo. Cool, we have the 4 pieces that we need now for the actual geometry. Now the last thing before I simulate that I want to grab is I want to create my colliders. And we kind of started building that already up here. All right. Okay. And to do that, what I can do is do a for each connected piece. And this is going to create a connectivity node, which is also part of the inside the assemble. And it basically will allow me to create an attribute for each one of these. I don't have one right now, so we need to create one. Okay, and so we'll say connectivity here. We'll give it class is fine. And then you'll see that now I have 3 pieces. And I can do some pretty cool stuff here with this. So let's go ahead and do a transform. And I want to change their heights real quick and their size. So the first thing is I'm going to change their size based off of their pivot. And so to take that pivot, so you know how in Maya you can hit center pivot? Can't do that in Houdini, but we have an expression that does it. And so we'll say $CEX, $CEY, and then you guessed it, $CEZ. And that is centroid X, centroid Y, centroid Z. That's how you center the pivot. Okay. So if you look at this and I hit enter, you'll see the pivot is now in the middle of this piece, which will allow me to scale this down. I want them all to be about 0.3, really, really small for right now. And we could play with this a little bit. We could say scale 5, so they look kind of like spikes coming through. And we'll switch it to VDB from polygons. All right, and we could say copy parameter, geo resolution, paste relative reference, logo crazy. There they go. And then we can say convert VDB back to polygons. really high res, but that's okay. And then what we can do is do an attribute noise. Position. This one I actually kind of want to try noise along vector. Yeah, we'll do noise along vector. We'll do Worley Cellular again. But in the, maybe not here. We'll say 0.1. 0.1. Did I do that wrong? 1. Oh yeah, there we go, 0. So I'll get these like nice little spikes here. Oh, I'm doing this wrong. What's going on? Just a little procedural rock. But I want to offset this a little bit, and we'll do that with the iteration. So we'll create meta import node. We'll copy this node, and we'll do that expression that we did earlier. So detail, quotation, paste that node. And we'll do iteration, 0. And I want to multiply this. So I'll say times 3, just so that it's kind of crazy, right? And so this is what we got. And so now I have these 3.
Hey guys, I wanted to jump in here. During the live session, I wasn't able to solve a few problems quickly, so I'm going to jump forward and to fill the gap here. Let me show you what I did. So for our 3 pieces there jolting through the roof, or the ground rather, we made a few changes to how the animation works. I added velocity and I decided to simulate them. You'll see that here when we come back into the live session in just a few moments. I am simulating, and then I simulate again with these pieces, but I inactivate them. So they're deforming. And then inside of the solver here, I have inactive objects that I'm using, essentially animated objects now, but I ran the simulation before. I know it's a little unclear in the live session, especially considering that I'm going to go ahead and cut a lot from this video here for you guys, just for legibility's sake.
I know what I'm going to do. This is one way to do it. I don't really like it, but all right, we'll say 50. Okay, and then we'll throw this into the .NET. And you might be right about the piece name. So let's say -1. There you go. Cool. Cool. So they just go up, but I want to add some drag on them. So we'll do a pop speed limit. So all of your particle forces will work, just so you know. Okay, so we want a maximum speed. Right now we're doing 50. I'm going to say max speed of 15. See what that looks like. Cool. They go up. We'll say gravity. So I want to slow them down. Cool. A little fast. So let's say 5. Okay. And maybe 10. One way is instead of gravity, do more magical effects, is use a pop drag. This will like freeze it in space. There you go. You get more magical effects like that. And it's kind of what we want, right? So we'll say maybe 1.25. Cool. All right. Then what we could do is take this and throw that into our out rocks lift, but I need to do an attribute wrangle. And we want this to be I at active equals 0. Let's get rid of this. There it goes. Cool. And now they're coming through. And they'll freeze too because they're being handled in a different simulation. Okay. Now I don't have the constraints in yet right now, so they'll just kind of come through like willy-nilly. So to fix that, also let's go to the edge ground and just turn off the display geometry for right now. We'll start building our constraint network. So we have a couple of them. So we have a constraint network here. And we'll do a merge because we need two, right? So if you remember, on the constraints, I have it switch from hard or from glue to soft. We need both. So we'll need the glue. And then we need the soft. And the one we'll use is the bullet soft constraint relationship. All right, let's just work on these two for right now. Okay. So for the soft, I'll go to 1, 1, 1 across the board. But for the glue, let's just go to 1 because I want to set the glue here. Let's see what it looks like. Oh, I actually have to put the glue constraint in. There we go. And maybe we'll give this a nice little color here. So guide option, we'll say yellow. And then here we'll say, oh, we'll say white. It's fine. All right, let's take a look. You can see they're holding together a little bit now. And they're kind of springing a little bit. Now the collision's a little off here. So for the rock lift, let's just look at those. Let's go to the bullet data. And let's show guide geometry and turn off the display, and you'll see what's happening. And you'll see, remember that convex decomposition I did for each piece? Well, that actually is happening inside of DOPS. And we'll go to concave. Now, it's going to go way slower, okay? So just be aware of that. All right, let's go back to the sim. Reason why I had to do it this way is because, like you said, the ground plane there, they're not going to go through if I just activate the attributes. So this way, they don't really exist in the simulation, but they're still being treated as colliders. Now, I do want these pieces to kind of break a little bit. So what we can do is increase the glue a little bit. Let's say 500. And then here we can run another SOP network inside of DOPS by using a SOP solver. Okay, so basically all this is running SOPs inside of DOPS. Thankfully, the SOP solver gives us the relationship geometry. And I could say, and if we take a look at this real quick, we'll go to the geometry spreadsheet. We go over here to the constraint. You'll see a couple things happen. So actually, it'll be better if I show you up here. So if I go to the geometry spreadsheet, which looks different in DOPS, I'll hit play. If you look here at the relationships, constraint network 1, constraint network, geometry, we go over here to the primitives, you'll see there's a distance attribute that gets created after the first frame. And I can read that distance frame and say, hey, when the distance gets this long, snap. And so we're going to procedurally snap our glue constraints and our soft constraint. So we'll do an attribute wrangle. And we'll do this on primitives. And we'll say if f at distance is greater than channel float dist. Remove prim 0 at prim num and the points. Let's promote this up. And what I'll do now is go to my scene controls, edit parameter interface, and we'll go ahead and create a float here. And we can say break point. We'll call it b point. Apply, set, copy that parameter, paste relative reference, and we'll set this something like point, we'll say 0.25, something low. You can probably go lower than that. And then under the bullet soft constraint, I'll make a few more changes here. I'm going to say stiffness 1.5. We'll leave dampening at 1. The glue looks good. And to see how that actually works, we can hit W. Let's give it a different color. Actually, I can't even see that. There we go. Okay. We'll hit W, or we can actually just turn off the geometry for now. And we'll examine this from a constraint network standpoint. And you can see what's happening. Oh, some of them are going blue already. And you remember how I said the gravity is pressing down? So we'll probably need to increase the glue strength there. So we can do that here. Let's just go to the maximum, see what happens. Now keep in mind we didn't add the constraints on the edge yet, so there's nothing to hold them down. Let's see if we add those edge constraints now, if there's enough to hold them down. So we move the output down here. Oh, I accidentally created an output. All right, so to do that, I'm going to create another constraint network, but this time I want to do it after we've introduced that edge. You can call this edge con, whatever. Okay, throw that in there. And I could just duplicate these two. Hold on Shift, Alt, let go. Put that in there. Cool. Let's give this a better color, though. We'll call this, I don't know. Oh, we'll actually cyan, though. Okay. And then for the con is already to 10,000. So let's see what it looks like. And these are inactive, by the way. So you'll see it is being allowed to break. But they're really strong. Too strong. So let's fix that. We'll say 1,000. Maybe we'll go 3. There you go. Look at that. And they're stretching, and then they break once their distance gets too far. Let's throw the geo in there. Okay. There you go. Look at that. Now we could probably reduce and actually start to get more of that folding up look. So let's go ahead and just reduce this to back to a 1,000. See what it looks like. And you have a, I mean, this is the basic skeleton. We would upper as the sim. So we have that. So now I'm going to import the DOM import. Bring the node in here. I only want to bring in my wrong drop down. Only want to bring in my ground fracture. Okay, so there we go. And let's get rid of this. That's all we're bringing in. And then we can do from up here, you'll remember, we have a high res now. So I'm just going to go ahead and duplicate the assemble over. But this one will go to the high res. All the way down here, we'll do a transform pieces. And now you have your high res. And there you go. The only thing left to do is to now merge these back in to each other. So we can take this We can grab the edge geo. No. Now, I think they're breaking a little easy, but also keep in mind the pieces are not that big. So it's time to actually up-res this. So we'll do a file cache here. Actually, I already built one. Let's copy that. We'll call this low res RBD sim. And let's go create now that top network. I'm going to teach you guys this later, but I'm going to create a network here to do that cache. Top network. And call this simnet. And we'll do a ROP fetch. Remember, ROP literally just means output. So ROP fetch. In the scheduler, I like to switch my single on here. In the frames and batching, ROP node configuration. And for generate win, all upstream items are cooked. Okay. And this will make sense why I'm doing that in a second. And then I can come in here, double click. Let's go see if we can find it. Here it is, file cache. And I'm going to grab this render right here, throw it there. And this should just be a single frame, I believe. So we'll let that go. And then let's duplicate it down, double click, grab the render, throw that right there. We'll call this geo, and we'll call this sim. And go up a level. And now let's drive this bad boy up. So we can add a parameter here. We'll go to edit parameter interface, and we'll call this, we'll do an integer here. Throw this under the RBD controls. We'll call it number of fracture. Actually, num fracture. And we'll call this numf. Apply accept, and we'll say 500 for starters. Copy this parameter. And let's go throw this now into here. Paste relative reference. That looks good, that looks good. And let's go see how insane that is. That's not that crazy, right? So we go probably higher. Let's do 1000. Blast. It's good. This is where it's going to slow down. Cool. Okay, and let's see if this is a good test right here. We'll go to the Boolean. It's going to slow down as well. Exploded view. There you go. A lot more pieces now. So we'll get more and more look. And everything, by the way, will update procedurally. Okay. So we'll go to the top net right now. Now we could do it up here. I'm going to say dirty all and then cook output node, or we can right click here and just go to, well, I got to do it from here. So let's go ahead and delete this node. That's good. All right, right click and we'll say dirty and cook this node. Save and continue. I'm going to go get lunch. I'll come back and it'll be done. Right? Like I literally will have my simulation. And like last night, for instance, I ran the everything from the RBD, which then runs my particles, which then runs my pyrosim on a shot that I'm working on. I did that last night. Woke up this morning, it was done. Nice. So I'll teach you guys how to do that for the volcano as well, so that you guys can work smarter. But I'll let this go. I'll stop this recording. All right, so this is not bad for like an hour and a half lecture that I just did right now for a bonus. Made a few mistakes with the animation of the ground pillars, and I did it really quickly. Given time, I'd model the ground pillars and then I would animate them separately. But for the most part, I showed quite a few tricks here. I think one thing is the glue constraint might be too long or too strong, and then the soft constraint's not strong enough. So we're not. It really looks very concrete more than like soil almost. So I mean, we could just change that. We can come in here and make a few changes and say glue. Let's see. It's gonna go a lot slower because the pieces are very small. But I want the constraints to break a lot faster. And what I can do here is maybe under the stiffness, we'll go to 3, 2, and then we'll leave this one really strong. But under the break thresh, let's go to, I don't know, 0.5, so they really don't break until unless they have a lot of force. They probably won't break at all. Yeah, so they're not really breaking at all. I think the glue is not too strong. This is the name of the game, by the way. You just iterate. You're going to see this when we get to the volcano. The name of the game is just iterate, 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 iterate. Okay. One thing that's happening here too is they're not propagating fast enough. So I'm going to lower the half-life here to, let's say, 0.03. So that what that means is they're going to reduce the strength by the glue strength by half of its current value that every 0.03 seconds. There you go. So you'll see more and more pieces now out here. What I should do is go and rebuild the constraints and make them on the edges. And so what'll happen is instead, because right now what's going on is they're to the middle, the centroid. If you do it to the edges, they'll act like hinges. But it's getting the job done. I mean, it looks pretty good. Maybe breakpoint, we'll do 0.375. And then for the soft here, we'll say 2.25. And we'll say 1.75. And then we'll say override angular stiffness. Actually, we'll turn on plasticity, so we'll enable plasticity here. Hardening, I'll do 0.5, and then rate of 2. Let's see what that looks like. Although, sometimes when you turn on the plasticity and you overdrive your settings, they start to jitter. Yeah, you can see what's going on. They're jittering, and they're flying off into space. It's not terrible.
Like I said, this is a different format than you would usually find here on the channel. Some people will find this helpful. If not, you can always check out the rest of the videos on the channel that are a lot more curated, a lot more edited down and polished for you. I'm not necessarily a fan of the unpolished work, but I figured I would still share this with you. I think it's fun. I think it's engaging, and I'm going to show some stuff that that I may not actually show on the channel. And then sometimes you'll see me get frustrated and have to solve some problems, which is something we have to do in the industry. Now, to be fair, I did edit a lot of that out so that we can keep this relatively short, at least to an hour. But on campus, this one took me almost 2 hours to do. So without any further ado, though, if you really like this, let me know in the comments below. If you want to see more of these types of video, let me know as well. But until next time, be sure you like this video, subscribe to the channel, hit that bell icon so you know when new videos go live. Be sure to check out the Discord community, and I'll see you in the next video.